Okay, so suppose that the function f at x is approaching 0 as x approaches to c, and we have f at x times by g at x as x approaches c is equal to 1. Can the g at x, can this part of the limit, can that exist? Okay, so let me remind you guys that by limit laws, that this right here means the same thing as this. So we can actually take the limit of f at x and then take the limit of g at x as x approaches to c. Okay, multiply them together is equal to 1. Okay, that's what that means. So we already know this is approaching 0. Okay, so instead of using the symbol 0, let's actually use delta. Okay, delta is what we use for approaching 0. It can be delta, or it can be any number times by, right? Times by delta. So this is a constant, but this is here, delta. Delta is really a function which approaches 0. It is not a fixed number. It's a number just really getting close to 0, but it's not actually 0. Algebraically, what does this, right, this part have to be so that, right, so that the algebra will cancel out to give us 1, right? Algebraically, it has to be the reciprocal, right? It has to be something like this. K, if there was a K, you would have to have a K delta. Only algebraical way we can cancel things out so that the product of the two limits gives you 1, or gives you any kind of constant, right? What does that translate into for the limit of g at x? So right now what I'm saying is as x approaches c for g at x, it has to be something that looks like this. But what is that? What is 1 over delta? This is something that we've seen a lot in limit at a point. This is something that is essentially 1 divided by a really small number. And what will happen to that is that it will grow undefinedly large. Undefinedly large. Which means this has to be infinity, so that the product can equal to 1. And this makes sense. Let's just talk a little bit more loosely, because all this symbol might confuse you. If you have a 0, a number that's approaching 0, right? It's really small, really small, and you want to make that equal to 1, right? Then here are a few different scenarios that can happen. We can potentially be multiplying another really small number, or a constant, okay, a fixed constant. Right? Ask yourself, can that be 1? Or a really large number. This two small numbers, for example, 0.001 times by 0.0001, there's no chance for this to become whole. Here, 0.0001 times by, let's say, 10, right? This will be still significantly smaller than 1. Now you may say, well, why don't you make this a little bit bigger? Okay, it doesn't matter how big I make this, because this right here, this is going to be fixed. Once you choose this number, it's fixed. This one here, I'm allowed to make it as small as I want. Right? That's what it means to be approaching 0. So it will never actually equal to 1. Now these two symbols, though, this one here means I can make it as small as I want, but this one here, I can match it to be as big as I want. Right? So I can always, so however small this one is, I can match this one to be equally large, so that the product will equal to 1. Right? So this is the only possible case scenario which the two numbers will multiply together to equal to 1. This is still tricky to think about because we're used to thinking about numbers as a constant. But like I said, this number and this number, it's not a constant, it's more of a function. So let me draw a function. Let's say we have this function, this is f at x. Let's say that's a number that's doing this. Okay? It's going towards 0. It's getting smaller and smaller to 0. So let's say this right here is like half, you know, and then it becomes maybe a quarter, right? 1/8 and so on. And let's say we have right here the g at x as a function which, so if that's 1, let's say 2 does this. So this is clearly approaching infinity, and this is clearly approaching 0. But if you take, okay, so for any x value, if you take that number, which is half, times by this, okay, let's say that's 2, it's going to equal to 1. Again, take another number, a quarter, right, also equal to 1. Quarter times 4, let's say. 1/8 times by, as long as this function is at the same x location, it's 8, it's also going to equal to 1. Right, so here it'll be really, really small, right? Let's say this is like 1/2 to the power of 100. As long as this goes up, maybe this needs to go up a little bit faster, just as a rough sketch, right? So if this goes up and the y value, the f at x value, sorry, the g at x values, this is g at x, and this is f at x, that value right there is 2 to the power of 100, then they're going to multiply to give you 1. Okay, and it does that for all value of x, no matter where you pick, as long as x gets really large. Enough explanation. I tried to give you the algebraic expression, the numerical explanation, and a graph explanation. Why g at x has to not exist. It has to approach infinity.